Define specific heat capacity. Well, we did the definition already. What is the specific heat capacity definition?
The energy required to raise the temperature by 1 degree Celsius of 1 kilogram.
Yep, that's it, and we did that before. From the data in the table below, it can be seen that the density of lead is 11.3 times greater than that of water. Explain why the specific heat capacity of lead is so much smaller than water. So if you look at the table here, density of water is 1000 kilograms per meter cube. Density of lead is 11,300 kilograms per meter cube. But the specific heat capacity of water is 4,200, but for lead is 126. Okay? So you know mass is density over volume. So if I have 1 kilogram, then you can get this kind of a bit simpler formula here. Density equals volume if it's 1 kilogram. You just have to change the units. So for example, if I have 1 kilogram of water, that means I have 1,000. They're in kilograms. They do something wrong with the units. 1,000 kilograms per meter cubed. What? Nobody corrected me. Mass isn't density over volume. That's a density is mass over volume. So if I have 1 kilogram, then that means volume equals 1 over density. So then 1 over 1,000 meter cubed is how much water I would have. And then if I had 1 kilogram of lead, then it'd be 1 over 11,300. So you can see the first thing is a kilogram of lead will be a lot smaller in volume than a kilogram of water. Okay? Also, you'd have to get your periodic table out. Do you have your periodic table? Yeah. Now, I don't really think they want you to mention the periodic table in the exam because you don't have it for the exam. Can you find lead there? What's it, lead? LB, is it?
PB.
PB, sorry.
That's not
200, is it? For the atomic mass, what is it?
It's not clear.
Here, let's see. Where is it now? What's it? PB 207. Yeah, 207. So anyways, 1 mole is equal to 207 grams. Now water is H2O, which is 2 hydrogen and 1 oxygen. So hydrogen I know is about 1, and then what's oxygen? About 16. So H2O, 1 mole, what is 18? Yeah, 18 grams. So you can see that sorry, I'm making this explanation really long, trying to get to the point for you. 1 lead atom will be about 207 grams divided by Avogadro's number, and then 1 H2O will be 18 grams divided by Avogadro. So which of the two is bigger? Well, the lead one. So I suppose my point I'm trying to get to after all of this explanation is that if you now summarize it, so if you look at the water, this would be 1 kilogram of water, and then if you look at the lead, this would be 1 kilogram of lead, because remember at the beginning we said the smaller volume, and not only is it smaller volume, but the lead particles are actually bigger than the H2O. So the H2O will be little particles in here, okay? Whereas with the lead one, they'd be much bigger, fatter particles in the lead one. And there's less space. So what is the consequence? Well, that means it's easier for the lead to have more velocity, more v squared, more kinetic energy, because with the lead, they're tighter together, they're heavier, they're bumping into each other, so there's not much freedom. And remember, temperature is just a measure of how fast the particles are going. So to say that this has more specific heat capacity, that means, you know, it can hold more energy, which means it can hold more kinetic energy, which it can because there's more freedom for the particles to move. Now it's only 1 mark. So what would you have to say after this explanation to get 1 mark? I would say the H2O is smaller than Lb, and 1 kilogram of H2O is in a bigger volume.
Smaller and more.
Smaller mass, sorry. Smaller mass than lead, and 1 kilogram of H2O is in a bigger volume. Therefore, H2O has more, what would we say, not opportunity. What's wrong?
Nothing.
What?
Nothing.
Tell me.
No.
What? What? You just randomly started laughing. What would we say? H2O has more...
Density.
No, I want to try and say like freedom or opportunity to have more kinetic energy. H2O has more scope, that's the word I'm looking for. H2O has more scope to have more kinetic energy, which would mean I'm talking too much, it's only 1 mark. That will do. There we go. Okay. So a lead bullet is, are you sure we didn't do that? All right. A lead bullet is fired at a speed of 350. At a target 200 meters away. What will be its vertical distance it's traveled? So you have to use the formula SY equals UT plus a half AT squared. Okay, and we'll call down positive and right positive. Okay, so what's the vertical velocity at the beginning? Yeah. And the G is 9.81, so it'd be a half. But we can't use this formula because he doesn't give us the T. So away you go. So we have to use the V squared formula. But do we have the V squared? What do we have? We have the U. No, we have the U, yeah. We have the mass, we have the U, we have the S. Yeah, so we have to use the V squared equals u squared plus 2as. So v squared equals 0 plus 2 times 9.81, and then
We don't have this.
we don't. All right. So actually, this question is only 1 mark, but it confused me because it has a couple of parts to it.
It's 200 meters direct.
Yeah, but that's the horizontal. So what confuses me here is it's only 1 mark, assuming I typed that right. So, but it has 2 parts to it. So before we can actually look at the vertical, we have to look at the horizontal, and we should find the time horizontally. So we're told that it is 350, 200 meters away.
Yes.
Okay. So horizontally, Sx equals 200. So S equals u t. There's no acceleration horizontally, so plus 0, a half a t squared plus 0. So this gives us the t is 200 over 350. And now we can calculate the sy.
So why is there no acceleration?
Horizontally there's none, there's only acceleration vertically. Sy equals u t plus a half a t squared. .6 is what I got. Yep. Okay, now the second part. Maybe if I put it onto this one, but then it's at an angle. Oh, I don't know what I'm doing. Here, MB, can you move that table closer to you? Okay. Right.
This.
Guess that's a tiny bit better. Okay.
I suppose you just have to put 8 zeros.
Now, last part is the bullet hits some sand and 80% of its kinetic energy is turned into temperature, into heat. So what is the increase in temperature? So when it hits the sand, how fast is it going horizontally? Well, what was its speed it said horizontally?
350.
350. And its speed vertically we have to work out. V equals u plus at. The u is 0. The a, what was the a? Can you read it out? What was it? 200 over 350, wasn't it? So a times t. So I get 5.6 meters per second for the vertical speed at the end. So to get the total speed both horizontally and vertically, we use Pythagoras. So this would be 350. So in fact, in the marking scheme, they don't even bother to calculate this, I believe, because it's so small compared to this that it's like the particle is still heading horizontally. You know, this is tiny. This is like 0.04. So most of the speed is horizontal. None of the speed is really vertical. So the bullet, as you know, when it hits the wall, it's still traveling pretty horizontal. It just kind of drops a little bit at an angle. Anyways, the kinetic energy is a half m What's the mass? 85 grams, wasn't it?
Yes.
Half m v squared that is 5208 joules. Now that gets converted into 80% of it gets converted into heat. So the amount of heat energy produced, 80% of that would be 4166 joules. So we can use now our delta Q equals m c delta T, and we're looking for the delta T.
So for the KE we use 350.04.
In fact, both will be acceptable.
I mean, if it was.
I used that. Yes, if it was different, yeah, you should.
have to
Yeah,
use the.
we should really be using the diagonal one. Yeah, to do it properly. I got 389 Celsius. So the lead bullet gets really hot after crashing into the sand. Now, I think it's mostly to do with the fact that lead has a very small specific heat capacity, meaning that it's very easy to heat it up very quickly. Yeah? Okay. 21 now.
Just 1.6. This is 1.6. This is something different.
Is that 4.66 or 400?
Sorry,
Double I.
4166. What?
I wrote it wrong.
Yeah, listen to Andy.
Yeah. And the 5.6 is the speed or the
Vertical speed.
vertical?
Yeah.
Can you roll up?
Yeah, this is 1.6. Because this is vertical.
Vertical distance.
I was right.
So how you get 5.6 is the
There's the formula on the left, Andy. V equals U plus AT.
again your the 1.6 divided by time is the speed.
1.6 is the distance.
The distance vertical.
Yes.
And if the distance vertical divided by time is the speed.
No, because it's accelerating. That only works if it's not accelerating, if it's constant speed.
How could you get
5.6, using the formula V equals U plus AT.
Okay.
Yeah,
U is
0. Okay, 21 now?